Hi everyone. Yeah, I had to rush and stop the video because of the times constraint that YouTube has. I'm trying to. I was about to explain a couple of more things over here. The first explanation that I wanted to give was regarding the ACF and the partial autocorrelation. So autocorrelation function will give you the values of autocorrelation of a time series with its lag values, right? So now, if the already lagged values over here, as you can see, let me just take you to the slide. Sorry, the plot. Yeah, so if you do not want to use the lagged values of these months and you want to directly go ahead and predict, then you can use PCF, or it's removes those indirect lag values or indirect effect, you can say. Couple of other things that I wanted to talk about was the difference between the cycle. So here, where is that? Okay, here is the graph. Yeah, difference between cycle and season, right? Although it appears to be same, however, if you can see, there is a difference, right? Yeah. So a cycle is fixed. Sorry, a cycle is not fixed. A season is fixed. Okay. And seasons are also small, and cycles are big. It's a huge effect. More than, I guess, 2 years is something which we can talk about a cycle. To give you an example, now, one important thing I'm not sure if you guys have seen over here is the Hodrix-Prescott filter was able to find a trend. However, the it's not showing a trend in the STL. So I usually use these two to see if yes there is a trend. Ideally, you can look into the slide. I keep saying slide. Look into the plot and see if there is a trend. So as you can see, there is a downward trend over here, and there is upward trend over here. Okay, that's what trend is. So now, one thing that I also wanted to share is, as it's sequential data, I was able to use LSTM. So here what we are doing is we are taking 43 features and one time step. So it's when you are doing LSTM, you have to use this time step. Okay, so that's why I have reshaped my data to go ahead and have the input shape as 1,343. Basically, it's a basic prediction over here. So it's a multivariate. So what do you mean by multivariate? As I explained in the first video, is I'm trying to see the effect of these variables on gas and power together. Okay, even though it says one, but definitely we can have a different. I have combined into one, but ideally it should be separate. So just for the video sake, I've combined into one. Now, one question is that I usually get: what is stationary time series? I have explained in the previous video on the assumptions. However, a stationary time series is the one where whose properties do not depend on the time. Okay, at which the time series usually get observed. Thus, the time series with trends or with seasonality are not stationary. Very important. So with trends or with seasonality are not stationary. Okay. I'm not sure if I have covered the multiplicative decomposition and the the additive decomposition. I guess I have, so I'll just skip that. Um, so what else? What else to go ahead and cover? Uh, so I guess that's all. That's all I wanted to cover in the time series. It's in a specialization by itself. So okay, yeah. So I wanted to cover what is a moving average versus auto regression. So moving average, usually we take or we consider or look into something called a error term or ET. We take into consideration the time that the ET is distributed. Okay, so if it's like ET minus 1 or ET minus 2, that kind of so give you a example. Let's consider we have an independent variable as crew our over here gas and pricing, and the ET that I am talking about is the change in gas and power due to one of these variables. Okay, so that's where that's where we consider the change for auto regress or auto regressive. We can go ahead and mostly the thumb rule, if I am not wrong, the thumb rule is the PCF that we see here is mostly used when we go ahead and do autoregressive, and ACF the ACF is mostly done when we are doing moving average. uh, that's the thumb rule that people uses. Both of these are, there is something else as well, like ARMA. So those are kind of box Jenkins approaches. Okay, and so what is ARIMA? So it's an auto-regressive integrated moving average. Okay, so there is something called a differencing. Okay, so differencing the differenced series. Okay, is the change between the consecutive observation in your original series. So that's what ARIMA is. So what is ARMA? It's a combination of A, R, and MA. So as you can see, moving average and auto-regressive combination. So yep, that's all about it. That's all I had for this part 2, a short one. I have done time series long time back, so thought of going through a refresher along with you guys. And okay, thank you for watching my video.